Good morning, good day, and this is February 23rd, 2021, Tuesday, and this is also your friend Engineer Suraj Singh speaking from Bharat, India, addressing professional talk to global community of engineers and non-engineers all because it is general talk, not very particular with certain formula or no formula. It's very ordinary talk which can be understood by everyone. And title is Civil Field Engineering, Designs, Construction, Methods, Contracts, EPC, AnnexSL, Organizations, Communications, Coordination, Quantity including quality, and why be behind quality of concrete and material and standard material. This is talk probably 273, I'm not sure. Maybe just numbering. Usual practice every day I try to share with you about issues of quality and quantity. Everybody understands quantity. This quantity, what is number or cubic meter or linear meter, we know that. Quantity is known to everybody. When you buy whatever item from market, you know you buy in certain units, and how much you buy, that is quantity. When you buy vegetables or you buy some other open items from market, you always try to ensure before purchasing whether or not that item is means to your requirement. It's not old, it's fresh, because you know that you know and you use every day, you consume that, that's a consumable product. You are very much worried about that vegetable or that food grain or whatever else you buy. And of course, when you buy something packed, you want to make sure that it is not expired, or it is which date is was that produced, manufactured. This is general habit of everybody, that we want something good for consumption. That's right. There you are concerned with how much you are going to buy and what level of quality that item has. Though this shopkeeper or vendor is not adding anything to that, it's not vendor's manufacturing. Yet you say, okay, why should I buy something which is not consumable? That's good idea. Means you should have quality product. That's right. But there you spend maybe 100 rupees, 50 rupees, 200 rupees. You are so serious about that. I'm happy that you are serious about that. You should make sure also. And if you are going to buy a little expensive item where it's manufactured and patented, then you keep off from that quality because you know it's patented. You might buy a scooter or a motorcycle. You know it's already prescribed what it is specified, and you don't understand all the specification, you buy it. I agree. You don't understand car specifications, what is brake horsepower of engine, how does it work. It means so many properties, parameters are there which are written on documentation of that car, but you least bother about that because you think it is company product and it is like that. You can't do anything in that. It's design product, it is design patented. Right? As you go on spending higher and higher sums, you won't raise many questions, but you raise questions when you buy very small, when you buy something for very small sum. This is natural and this is conventional practice of everybody, whether you are educated or you're not educated. But I'm surprised over it actually. You want to spend millions of rupees to buy some house, but you do not ask anything about its quality. You simply think of finishing its quality, very attractive house, aesthetic and very good color. Like you ask very good color of car seat, Means you have an option on color, you see, or you have an option in car color. So your option is very much limited when you spend higher amount. When you are very serious when you buy a small amount, a small item like food grains or like something which you can see, oh, this is small guy. I raise questions. Can you raise questions to Tata or those who are manufacturing car? Can you raise questions to BMW owner or Mercedes owner? You shall not raise any question because you have no access to them and you do not know anything about car. Though car is an engineering product, everything is an engineering product, building is an engineering product, and there is nothing else which is not an engineering product. But you are off there. Means either you are not having capacity to raise question there, or you are scared, or oh, okay, it's all right. We'll see later on. This is under warranty, this and that. Because vegetable is not under warranty, and it's under warranty. That's the difference. Cars in the guarantee of 1 year, 2 year, 3 or 5, whatever it is, and there's some limit. Okay, they'll maintain you by a hour. You don't ask any questions. Whatever you buy means which is manufactured product, you don't bother about. You to ask that one because you don't have capacity. I think even in those who are educated, who have capacity, don't ask this. Unfortunately, you are spending money on television to see news. You don't ask whatever of news. Why are you giving this news? Where's analysis? You are not asking anything. You're just going on spending money on that, and you think it's all right. Though they play with your money, they play with you. You do not bother. You know how many cars of I think Volvo was well, and so many cars manufacturers withdrew their cars after use of so many years because there's some problems in cars, but they did not raise cost. Nobody went to court and all that. This happened. You spend millions of your units of currency for buying something, and you do not know about quality of that. Nobody is guaranteed that one, and okay, we'll see. It's for everyone's buying, but for a small amount you are worried. That's my question: is why are you so serious about small amount, or why are you not serious about that big amount you spend? It's not a reasonable question. I think it's a logical question. You should not cross my question. It's a very important question. I spend I spend 10 rupees to buy a cup of tea or small cup of tea, and I fight with the vendor. Sugar is less and this was well boiled, and you can say, I'm just giving an example. Means very small level vendor you have authority, but big level vendor for me both are same. A person who is selling a cup of tea or selling vegetable, same thing as 5-star hotel. You go to 5-star hotel, there you don't speak anything. Though that's 2 days old vegetables giving you, or 2 days old soup you are being offered, you don't say anything. That's where I'm talking of. Not only you, all of I'm talking of. Means you spend higher money, and those people are very big to whom you pay, and don't speak anything because they are reputed one. You measure quality according to reputation, or you measure quality according to product standard performance. Big question mark. That's why it's a big question mark, and I am therefore pointing out this. My definition of quantity is different. Your definition may be altogether one. Quantity, when you say, when I consider quantity, for example, whatever quantity is there, it must include quality. Otherwise, I will not accept that product according to my understanding. So look, basically, I am an engineer. Engineer gets mind. Engineer has mind. Without mind, you can't become an engineer. No way. It's very much true. We must have mind to become an engineer. We must have mind to become a medico. We must mind to have some analytical degrees like chartered accountancy, like wherever you spend cost accountancy, or you can say where mind is applied, where mathematics is applied, where analytics is applied, and where tax is applied. I think that's different education. I don't consider analytical education. So when I say I am an engineering person, I am an engineering student or engineering professional, it is for sure that I must think, I must analyze. That's my basic fundamental right. And my fundamental education, it forces me to think. And if I am not able to think, I am not that qualified personnel. If I don't have capacity to think, that I copied and passed or something, I procured some degree and I am declaring fake, that I'm fake engineer. Engineering is done with power of mind. Medical science is done with power of mind. Similarly, wherever mind is required, those professionals must be very smart. Maybe they don't speak much, but they understand very well, they write very well, they think very well. And of course, they commercialize to some extent. I'm not going to that commercial talk. Nowadays, medicals are commercialized, and generally all are commercialized. When MBA comes into action, means everything is commercialized. Nothing remains a service to society. Even engineering, medical, and all others are commercialized. And commercial, when the commercial point comes into this, then the quality, I think, is down. Unfortunate it is. Commerce includes quality also. It's not for just like, so quantity includes quality. If you pay money, you must get service, and service means quality service. For someone, quality is nothing. For someone, it's everything. Suppose I am a human being, I don't have quality, my conduct is not, I don't talk well, I don't treat people well. People will say, this person is very bad, dirty person doesn't know how to handle, or this person is not to our requirement of quality. Yes, you are right. You feel bad, right, about some conduct, bad conduct. This means there is some lapse in my quality, which you think should be different. You understand some quality there, though there is no specification of quality for human being. Every human is different, every mind is different, every body is different, every conduct is different. But it's no, this person should be polite, should be diplomatic, should talk well, should be sweet talking. You have certain specifications. So there are some specifications according to everybody. You want someone to talk to you in a good way. But you also are expected that. Means people expect you also to conduct strategically. Well, I'm big man, I right to say everything. No, it's not. Question arises, why should we consider quality as top criteria? I would say top criteria. Or number one criteria, because if quality does not exist, my duty as engineer says I should not accept that. Even if there is 10% defect, 5% defect, defective item should not be accepted. Lapse of quality means defect. Technical defect or visible defect or performance defect or whatever types of defect, I say this is defective material. And why should I prefer to buy defective material? That's big question mark. Means after all, if I make payment, I should get return. So quality should be considered from very different aspect. It's not my desire or your desire. Everybody makes payment for something, and that payment includes quality, even though it's not defined or specified. Even though it's not specified, it doesn't mean it should not have quality. Quality is quality is quality is quality. Is a must, is a must, is a must, is a must. It may be building, it may be structure, it may be product, it may be consumable item, it may be your service to someone, whatever it is. And because quality is being deteriorated all over the world, quality is being, not cared for, and we face losses everywhere. Losses not money wise, but otherwise. Quality control and quality system control and general control. You won't find such statements in books, but quality controls have been there for decades, I think for centuries. They might not have been defined, but by practice, by virtual world actions, people in past, in history, understood quality, and maybe they could not define on papers, but they knew what quality was, and they did their best. Examples are available. Quality products is still working, like many 100 years old structures, brick structures or not brick, stone structures. Quality has been working, and if you see natural products, or you can say universe in which you have been living, this solar system or whatever solar systems are there, whatever product of God is there in terms of planets and skies, they all have been working since they were constructed, they were delivered, or they were installed. I can say installed plants because all planets have been working, are working, and shall be working. This means there is huge potential in them, quantity wise and quality wise. That's why they have been working without repairs, without maintenance. We generally call maintenance contracts, or we say annual maintenance contract. We give AMCs, we pay them, but here we are not paying anything to anybody about use of universe. Think of if you have to pay, if you have to pay to universe use, like you are using sun rays, you are using air, you are using rain, you are using skies, you are using soil. These are all natural products. If bills start coming to you, pay this much for sunlight, pay this much for all these materials you are using, where do you stand then? What shall you do? You are getting something free, free of cost. This body you got free of cost. This universe materials you are getting free of cost. Their services you are getting free of cost. So you never think about that. Really? When you have something without any efforts, you don't value that. Same thing applies here. Natural service you are getting, you don't value that. Something is given to you free of cost, certainly you won't value that. And when you pay cost, you will worry about that. I am paying you this much. Why you are not giving this service? That point lies here. So when God gives you everything, of course it is quality system. Complete system is developed, has been developed, and it's still working. Why don't we observe and understand this phenomenon of nature, of God? God here, I'm not naming anything. Whoever, howsoever one is, power, superpower. That power teaches everyone that one has to work in system, one has to build a system. If you cannot build a system, you have to be part of a system. And whatever system exists, that should perform quality wise as well as quantity wise, qualitatively as well as quantitatively. These two words we used to write qualitatively and quantitatively during our technical writings. But it's not only technical writing, it's general writing as well. Whatever work you do, you should do quality work. Whatever you think, you should think quality. Of course, that comes to mind, but it's often expelled out, and we keep only good ideas with us. And we teach everybody, don't do bad, do good. That teaching is for others, but for yourself, good or bad, both are same because you are interested in money making or in commercial angle of that. Means there's no use of giving more examples about this, means how we should do, we should not do, because more or less whole world has turned into commerce. Even medical service has been converted to almost commercial world. You have to pay millions for your treatment because of equipments, because of expenses, because of expensive buildings. But service of doctor should be in interest of humanity, because that is required, that's expected, and that's actually quality, but it's not done. Similarly, when you buy some structure, some house, you have every right to raise question, but I don't know reason why you don't raise question, because there's shortage of housing. This could be a reason that everybody wants a house, and particular in this country ours, where house is very important item. In our country, India, maybe it's not very important in Europe or in USA or in England, because the houses are so expensive there, and they can't save that much out of their running. Very few people think of owning house in those areas of world. But in our country, India, Bharat, everybody has an interest to whatever to do, whatever required to do for getting house. And this is whole time objective, whole life objective, you can say. Having house for a common man, okay, for riches it's okay, they can have 10 houses, no problem. But person like me or like you, a very very common person, lowest profile of commerce or lowest profiles of wealth, we have not very much wealth. For them, house is a lifelong product, lifelong achievement. So when your achievement is lifelong and you buy something without even thinking of about quality and what sort of achievement, what sort of aim you are having, these builders, these promoters, these people, contractors, and all those PPEs, contractors, they all play with people. Governments are also involved with them. Governments no different anyway. They are also involved, and they just say, "Oh, we are doing this," but quality angle is missed. And of course, quality means every quality. It's not only work quality. It means quality in designs, quality in safety, quality in planning, and whatever you say, where work is done, that should be quality based. Now, my understanding of quality is same as real understanding what ISO 9000 or Sigma or some others speak about. Your improvement should never stop. You should never say you are perfect, and you should never boost that quality. You may say our quality is so many percent is effective. That is okay. Effective is not 100% because it's very impossible always to have 100% achievement in quality. But you may say we are having almost so many percent success in quality. Just like this, so many pieces can be accepted defective out of so many millions, as Sigma states how many pieces are there, how many are defective. If it is to this percentage we accepted that, of course the percent is very very small, and more than this we don't expect. And we always keep on improving our performance, our quality, our working method. Everything is kept on improvement all times to come, and we try to minimize our defects or defective works. That is general meaning. But question is that is quality related? Is quality related to product or to system? That's important point. System should have quality, which also doesn't guarantee that your product is going to have quality, but it is expected that your product, because it has come out of system, should have certain quality criteria. And that's very important point, that because you are abiding by some system, you are conforming to some system, and if that system has been designed well, has been kept under preservation of going to have complete delivery of quality work, and this system is also updated every time, means it's reviewed many times, and then if there are some information available, those are incorporated into the system from time to time. And quality status, quality requirement, and quality result deliveries, you can say, are further made better, and it goes on and on. It never stops, and it should never stop. That is sole purpose of quality. Means we have to understand quality from each and every angle, from each and every point. We cannot simply say that this is over, at some point it's over. It's quality work we have done, and we have done what was required. I'm very much particular about structures, about, I can say, whatever types of structure, particularly buildings, oil foundations, you can say. And of course, I know for other structures like flyovers and bridges, or you can say structures are very much standardized, where people, experts move all time, or where the standard repetitions of those is expert contractors and expert engineers. I can't say about them. Maybe generally they are not handled by illiterate. Those objectives, those projects may be called quality projects, but there are reports everywhere that this bridge fell, that bridge fell, this happened and that happened, this retaining wall or this failed. It is, it's seen everywhere. So we cannot even be sure about that aspect, that structure. And buildings are of course very much prone to bad quality or to unacceptable standard of quality. This may be buildings, controlled by whosoever. It doesn't make a difference as far as quality is not achieved. And 95% cases which I have observed are not to mark. Of course, maybe overseas some areas, to some extent there could be quality like Abu Dhabi, UAE, or you can say Qatar, or before when I was in Iraq in 1981-82. Of course, I was too young that time. I did not know what is real engineering, and I actually started my practical learning from Iraq itself, because in our country I was in sector of government or you can say authority to supervise jobs, and I did not find any level of quality that time. It is unfortunate to remind and to recall that time of my young age, 1975 onwards. People did not, nobody talked of much quality. Actually, there was no name quality. People used to call specifications only, and they did not explain what specification was. Means it should be according to specifications, and nobody read the specification. Nobody did care for that. And if I just met one of my senior, I asked for specification something. He said, if I give you specification, you think I should stop? I want my work stop. I mean, say you shall stop this work, and I don't want work to stop. Means this is a very raw statement I'm making. This happened with me actually. Means of course I was too young, very new in engineering world. I was a student, like you can say, but I did not hear any meaning any time this word quality from my seniors or from contractors or from whosoever who have been involved in building. I've been involved in building that time. And even one time I was on site looking after job, supervising job, and it was, there was in those days we were using lime mortar, not lime cement mortar, lime mortar. And there was, it was 75, 76, I think 75. We had one block and a round trench in which mortar was mixed by this revolving around using this animal and grinding mortar to maximum fineness, I'm sorry. By chance, one superintending engineer of our circle came to site and visited site, inspected, and asked me, "Are you aware of specifications? Do you know specific? Are you reading specifications or no? What specification is there? Tell me." Well, I didn't know that. You don't know specification? How it is when you are working on site? Well, I said, I was not given this because the specification was not given to everybody. It was kept under office controls. Okay, you read a specification, you come to my office and tell me you read or not. Just instructed me like that. I told my immediate senior, he was laughing. He was laughing at that. Well, what I'm saying is that it's really a new person who comes. He does not know everything. He doesn't have complete information. But everybody has employment. You have to work. You are very young, you do not know anything, you could not get this information from your education level. But in field, this is a different world. Means you have to do according to contract requirement. But contract is also not with you. You are very junior person. Contract remains in custody of high ups. So what I say, only job was to see what contractor is doing and just you how much use, instruct, and then measure and make entries of those. So you can say just staying at site, supervise work, and then measurements, and then converting those measurements to variation or billing, and making bills and submitting every month. I think that was major role in those times. So you can say it was like a quantity surveying job, not engineering job. Means just take measurements, length, breadth, height, numbers, and this and that, and entries. And of course, there were no computers in those days, not even calculators. So everything was manual and in fits and FPS system. It was fit inches. We had to convert those fit inches after measurements into metric units, metric calculations. So most of time was consumed in calculation from fit to metric and metric to this and billing and that. So job of engineer was actually confined to valuation only. And that valuation to not modern valuation or professional valuation, just billing you can call it, not actually valuation. There's a difference in billing and valuation because valuation is a subject, professional subject, but billing is not that much professional. Billing is very common word, you can say just bill it out, or just valuation is something else, you know. So why I'm saying, I'm just giving an example, means how life has been. Means you cannot learn every you can say topic. Of course I should say you cannot learn about every topic from your academic centers, institutions, because they are too, those people who have to teach you, professors and lecturers, they too are not aware, they too are not exposed to quality system. Their job is only to fulfill teaching about syllabus. What is syllabus? They are not interested beyond that. They will be happy if they can deliver you lectures on subjects you study. I think that's only objective universities or institutions do have. But life is not bound by university or institution. Life is bound by practice and work. As many projects you do sincerely, I think that is added advantage, that's added qualification, one should say. You cannot qualify yourself by certification of educational degrees. No, that's not enough. That is just, you can say you passed through, you have studied theoretically, but practice is more important, more powerful. If you want to study subjects in your university, it will take hardly 6 months to 6 months or 3 months to just learn one subject. I don't think more than this you need. But if you say you have to construct some building, you have to learn whole building may take 1 year, 2 year. That project may take 2 years, 3 years, depending on speed, and so you can say you have learned many subjects there. While working for 2 or 3 years on one site, you think you have done one more diploma or one more degree. You can say that. What's wrong with that? So it's not theoretical, but it's theoretical as well as practical. You deal with every resource, you deal with every hundreds of drawings, you do hundreds of specifications, or you can say when you sincerely do that, you are bound to do there if you are paid for that. You can't run away, you have to do if you want to move further in your profession. So, of course, quality you learn there, but you maybe you are not habitual of learning by heart, but at one moment in time when you are trapped somewhere because of lack of doing good work or quality work, you have to learn and you are punished, and one is punished. So I have seen many instances in my life where, because of my lack of experience, lack of knowledge, I did not have much knowledge about what was asked by those during work, and I had to face such adverse situation many times because of not having adequate experience of quality working and quality system. But as I said before in start, that I started learning in Iraq, and I still remember those days, though it's far behind. It was 1981, 82, when I was there, and I was not very much practical in engineering because I was just new. After passing degree, I passed my degree in 1980 and my diploma in 1974. And you know, those education of this very, very small consideration for me. I don't consider that education very high ups, and even if you pass MTech or PhD, I also don't consider that to teach you. Theory is fine, you can say theory learning is fine, but as far as quality is concerned, projects are concerned, these don't give anything. If you want to do projects, if you want to learn projects, you can learn only thoroughly on sites or while you are doing a project. You have to go through all documents of project, which are hundreds of documents, thousands sometimes, depending on size of project. What sort of project is that? If it is a road project, I think you may not learn that much as you can learn in irrigation project. And if you cannot learn that much in irrigation project, if you have some structural project or building project or some plant project or some other place where you will find your chances to see thousands of technical documents, contractual documents. I have seen even tenders where thousands of papers are involved. So actually, you read them and understand them so that you can apply them on your work. That's education. Now it depends upon how fast you move on that. Once you are habitual of reading those documents, then similar documents will come for other projects. And you know, okay, fine, this page. And then you start reading pages rather than starting paragraphs or rather than starting each and every sentence. So you read diagrams, you read drawings, you read standard drawings, and you read all these documents. And many times you read whenever required for procurement, for approvals, for work, or for site deliveries. You come in abreast of that system, which is for you, which is for project, and without which you cannot move further, and that is beauty of projects. So when I compare my knowledge at time when I was out or in university or in polytechnic or in studies or when I passed out degree, that knowledge level which went on changing every 2, 3, or 5 years, and I felt that I learned more and more in quality, actually speaking, not in quantity. Quantity is very common, quantity I can't claim, but system of working, methods of working, involvement of working is a big question mark. I still remember one time our people did backfilling without taking into consideration layers filling, backfill, and they did it. So question came up in meeting: you have done backfilling without layers, and where's compaction report? Means it was a question. Backfill layers were done. No layers were followed. They just filled in. And sometimes it happens, you note, but it's also beyond your control because work is so fast and people don't understand everything. Okay, we have done it, and consultant did not say anything. So there is different approach. Those people think consultant did not say anything. This approach. But that question was raised, and it was made a joke. Okay, you did not compact. Fine, we'll accept. You bring a Traxler machine and do it now. What's Traxler machine? Traxler machine is where railway track is. On railway tracks, the machine moves to compact below railway track, and there's also tracks the machine is called. So it was joke whether we cannot bring tracks the machine onto building. It moves on tracks actually, and compacts straight up below railway track. That's very important point actually, but it was in meeting, and so we had to face all this. Means to understand quality itself, you have to understand what quality is. What is quality? What's the difference between quality and workmanship? What is different workmanship and without workmanship? This you understand only. It's also an analysis type. In procedure itself, you have to analyze what procedure gives you what. That point I try to stress always, that We cannot take something for granted. We have to enter something when we want to know it. We have to dip ourselves. We have to immerse our minds into that. Of course, for a while, not every moment, but whenever is necessary, your free mind, and you can go through these documents. And you once you start going through documents, I think that's your change of habit. Either you don't do anything, just sit down and work on site like a fat mind person, and only do not say anything but accept everything and call yourself engineer, which I don't. Your job is to see first what you have to do, and that only documents tell you what you have to do. And if you, I see people are not interested in documents, and they are not interested in office works. I have met many people of overseas, means because I have been in international community during my career. I I worked with almost about more than 50 nationalities, Arab nationalities, non-Arab nationalities, English nationalities, European nationalities, Pakistani nationalities, Far East nationalities. You do that. Uh, common base in civil engineering is that site work is more important, and on site you will find 95% people run away from taking headache of documents. You won't find many good coordinators. Maybe very rare you find, rarely. But you will find people interested in project works, on site works, you can say. They can run on sites, they can bring this machine there, that machine there, they can start excavation, they can do everything. In that, they are very too much dynamic. Of course, it should be, because that's the most requirement. Ultimately, whatever you do for work, for physical work, and physical work is an object in engineering. Though it may start from conception, from feed, from this, from that, there's so many stages. After moving on that, you come to site work. Site work is very important part. Nobody denies that. But site work itself includes thinking, which we do not understand. If you understand site work, technically I would say, not physically, if you understand site work, how work is done, really speaking, you have to refer to documents. You cannot simply say, I have experience, I have done it. Yes, you have experience, that's fine, that's why you are there. If you had no experience, you won't be there. No, you won't be there. You are there because that person who employed you wants your experience to be used for this project. And it's you. If your project experience is same without going to documents, then I think you can't control project. You can't control project. You must know everything about what you are going to do. And if by chance somebody does wrong for you and you learn wrong, you'll say it's my experience. You can't say that. You must know what's required, and requirement is very important. Requirement, when I say requirement, is whatever is in drawing, whatever is in all specifications, what is in the contract, everything should be done to comply with all those requirements. Contract requirements, specification requirements, drawings requirements, and whatever else. If you do not know that, or just copy some, okay, I'm copying that building because this building is same as this building. I'm copying, and then this is, you're not. You can say you're not a professional. You should not copy. Because what copy is? I was in Doha on a project, record center, where I was in charge and going through drawings many times, and I was surprised to see that in that one drawing it indicated that it is a swimming pool. So I raised question to consultants, what's this? I was laughing. Oh, this is cut paste. It told me that oh, this is cut paste. There's no swimming pool in this. What I'm saying is, people believe in copy paste, and when they do this, they don't even check it, what they've done. So advantage of computer this is that you are also misled sometime. So, only solution out of that misfeeding is that you have to do yourself. Once you start doing yourself, and you will enjoy. I can say that. You don't start, you don't enjoy. If you start your own character, if you want to build up your knowledge, if you want to lead yourself to your own development, I mean to say, you have to lead yourself. You have to think for yourself. You have to move for yourself. And remember, people watch actions of engineers. All people watch actions of engineers, but they don't tell. They backbite, of course, but they don't tell. You are an engineer, I am an engineer. For public, we are responsible. We are educated. But this must be seen in work. In work, you don't find that quality as you expected. And even after giving the assignment to someone, that person also doesn't have that knowledge. If I say that way, it's really difficult to learn them. How can you learn something? Well, it's not per records, it's not per requirements. So before doing before doing something on sites or on projects, you have to completely understand, you have to completely analyze requirements, what requirements are. And requirement is very important word here. It's not verbal meaning of this. But you have to inquire out, you have to question yourself. You have to question yourself and you have to go through documents and then question yourself what this page says, what other page says, what other book says, what's practice. But when such everybody understands, which role you are assigned, what you are doing, what time you are coming, what time you are going. It's all clear. So we must have that capacity in ourselves where we can say we are self-readers, we are self-analyzers, we have capacity to analyze ourselves, we have capacity to reject myself also, I can say sometimes. When I usually say when I decide something, I can't change that. Even if it gives me loss. I made a decision. That's it. Only its implication, its application, its implementation would tell answer whether it was right decision or it was wrong decision. That capacity engineers should have, because engineer's mind is very powerful, remember. Mind of engineer must be very powerful. And if you are not having clear mind, concept mind, power of mind, you're wasting time in engineering. Go home and sleep. That's what I say. If you are a career engineer, you have to do a lot of work. And documents reading is one of them, document analysis one of them. And maybe you are higher in authority, you are making those documents for others, for those bids. Then you may go through document, you understand, and you can reproduce that. Or you use same one on your papers. In that case, somebody will ask you about that. And tell him, yes, it's not mine, somebody else. Because you cannot pull credit from others' activities, you have to do your own job. So it's very important point, I think it's quality point here, that if you are doing work, because it is done like that, you don't understand anything, this thick books, thick written documents you don't care for. And how can you achieve quality then? Some senior person has written something so to do, and then some junior came and he spoiled that, or he didn't care for that, then you are left alone. So my point of statement is that quality aspect cannot be taken for granted. And if someone takes it for granted, that someone is not a professional. I should simply say. People do not understand profession. In general public, what is seen is building or structure. What is seen is that. So they say, okay, I got it, but this is my practice. this is my work to be done. So that's very good. That's very good that you care for that. It must be cared about. So my point is, quality cannot be taken as if something very extraordinary. It's a part of job. You don't have pride that you are doing quality work if you are not doing. I've seen people, they never been on project, but they are project monitor. It happens. It is not easy to work under quality. Easy from professional viewpoint, I say. It's not easy to inculcate in yourself the power of quality. Quality statement is not a statement actually. Quality is a commitment, like product is a commitment. You may publish anything until you yourself experience. I don't understand, you can also understand quality. Now my point of view is how to handle quality, how to achieve quality. I've taken more than 50 minutes in talking journal, but how to do it? First of all, when you join some organization, you must know about that organization from quality viewpoint. Forget its ordinary identity. I'm talking its performance identity. You have to make efforts yourself. You have to apply efforts yourself on your own build up, because if you are a quality person, your approach would be different. If you are layman, it's a completely different one. When we start something, when we do something, project or new work on that project or new item, whatever, or continuation of items, we have to coordinate drawings, documents, everything. It is to be done according to methods. This is not futile exercise, what I am saying is fragile. No, it is real exercise. This activity I am talking is your own activity. Laziness should not stay with you. Laziness should not stay with you. Point arises here, can we do it? My response would be, it is very easy provided you have determination, you have dedication, you have will to achieve quality. And if you cannot achieve quality, whatever you produced is worthless. You have to produce quality. That is basics engineering, If you can't achieve quality, you may say you are engineer, but you are quality less engineer. Your product is quality less. I am not talking commercial view. I am talking public and real view. If you ask someone, do you believe in quality, or where you are in quality? You may find some answers, maybe 2 or 3 answers, not all answers, because that person who is answering might have again forgotten, and those want to depend on your service to them. Now, quality is open to everybody. It's not secret. After all, why should it be secret? My point is that why should it be secret? Nothing of that sort exists. It is quality. It's part of job. It's part of product you are going to produce. It's quality is like soul in body. Body can be given pain. Body can be given force. It's impacted on what was agreed. We can say in our life that my home should be like this, my work should be like this. Imagination exists. Hypothetical ideas come in. But we do not know our capacity. We'll do when it comes. I talk to many people about something. Okay, they will do it when time comes. Why do you wait for time comes? When it comes. You are sleeping at night. They may be standing someone, you're not opening your door. But maybe you are scared, the person. But that doesn't apply. Always. Quality is a system. And within that system, there are so many low level systems. So we have to stress on system rather than in isolation of only some items to do with quality. What is that system? That system is like universe is working. That system, though is not universe system devised by engineering professionals. So that system which we are going to talk, already we have talked that system, but talking again and again is required. Because in beginning of learning you will not take it seriously, but remember that system is very useful. That system makes your family or a neighbor. Quality is very much required from everybody. Not only reference I am seeing as 9001, 2015 or others, this only reference. I am not saying you are bound by that. But if you want credit from them, you want to follow them, you have to follow them. It's not that they only guarantee something. I don't accept that. They don't guarantee anything. Neither ISO or Sigma. Nobody guarantees everything. They can't guarantee. How can they guarantee? They are not working for you. You are working on your projects. Those people only can advise, but we have to follow. This is professionalism that these systems have been devised. These guidelines have been devised and published. This is only for your support. Means ultimately you have to decide your quality. You have to confine yourself how much you can achieve. I am sure no one can achieve 100% because of many reasons, because of loss of continuation, loss of continuity, and full swing happens for a while. For example, you are doing concreting, pouring concrete. Concrete pouring has some moments when it's full swing peak, and when there's nothing, you're just sitting and people are smoking, some doing something else, or taking some cold coffee or tea in hot sun. So all time changes when transit mixture reaches site. You are excited in the beginning, but after many transit mixers are delivered, same kind of testing is done. Routine test, slump test, or you can say water test, or you can say air test, or temperature test. Water tests are conducted to relate to consumer, relate to your own definitions. What temperature should it be? And you try to stick to that. Means to some extent you are following, and to some extent you are not complying with. All that ignorance, all that quality less actions must stop. Civil engineering is a profession in which you have to do hard work. No civil engineer can stop from them, can run away from that. If you want to be continuously called civil engineer by others, this means you should have good reputation of work, you should have good response to people. That is very beautiful idea, good idea. Quality organization is very, very important. Quality organization. As a company or as an institution, it doesn't mean what we say should be read, what we command should be read. There is a format, or a structure which is called AnnexSL. It has been effective since 2015, and you have to fill up for your own work. Guidelines are available. Previous arrangements no more. What? If you are ISO 9000, year 2008, year of actions, that some management documents you have, like AnnexSL certificate, it must tell you where you should buy. That system, if you follow, you may get something. I'm not saying you'll get everything. You may not get everything, but something. A kind of structure of your system, and if you use that, you may get to some destination, some objective. I discussed that in one time lecture in time. Then I moved on to construction issues of buildings, then supervision of buildings, and also now it is you can say EPC, work, EPC contract that I explained yesterday, EPC, AnnexSL about EPC. Well, I think EPC is not small contract work, it's big contract work. I had experience on EPC from Libya. I had experience. When I went to other countries, every country has system, has specifications or contract, you can say ideas how to do work. That's very important point. We should not clash with. Rather, if we can follow it, follow it. If you can implement it, implement it. Or if you want to practice it, practice it. Practice means when you implement it, before that you have to train yourself. That AnnexSL has a structure of 10 clauses. You know them. I explained many times, starting from scope, ending with improvement. There are various others in them. Means complete structure is there. You can say, references are there. References, then many more, terms are there. Context of organization, leadership, planning, and you can say all those points are there which we must understand. And that's not difficult actually. It's for purpose of interactions, inter-information to others. EPC, when we call EPC, means it looks big. EPC. It's engineering, procurement, air conditioning. This is. When we say EPC, means it is something you are not going to be given design. You are not going to be given. You have to do your own design. You have to define everything in that design. And if it's all, you can say, on products, total responsibility. You have to take complete, and you will be given, of course, relevant people. Those structures rules we have to apply on EPC as well. In this EPC contracting, you have to design everything, and maybe you have to define feed also if it's not available. Means design itself is very big job, where hundreds of equipment you have to install. this this part of design. What to do in that case? Point is that how can you do that? If is on your screen, you'll find AnnexSL. AnnexSL ISO 9001 2015 QMS company. QMS stands for Quality Management System, and this is regarding EPC contracting facilities and where buildings are involved. Yesterday, I had some discussion on this. You can browse onto this, move on to pages and see what we discussed. This is system about, and we talked about the system. What is the system in this case? And we moved on to that, and then who is responsible, who is not, what is the structure, what are these requirements, all were talked of. Then we say, okay, this class 1 scope, what is scope should be. So there is a description of that, what you have to decide, and then you can say all these definitions were there. We'll come back to them. Let us go to at least see what we studied in this last time, and then there is number 3, I think clause 3. Come on. Yes. Yeah, there's some descriptions of these items I gave to you. I explained about components, elements of certain processing facility. What are included there in general, that was explained. What was in general? We explained about natural gas. We explained about wells, land requirement, then plants, liquefied natural gas, all these intake piping. There is a lot of that. We talked about this. I don't want to repeat that. You can refer yourself. Then we move on to this components brief. This components brief, like you can say technical little brief. That's very important point to understand when you do some job. And even if you make a document of AnnexSL, you have to define so that everybody can understand what to talk of. Whatever knowledge you have to thrive in that knowledge. So, LNG tanks we started with. We have to explain something so that you can understand where we are, what we say. You all might have seen LNG tanks, of course. Even then, I am giving some brief knowledge to people. These components are meant They are meant to used to store liquefied natural gas. Now, say capacity was 80,000 cubic meter per day. Uh, Once you understand quality, you can do good perfect, you can deliver required material, required product. But you have to understand that quality first. You have to define that quality yourself, or engineer has to define that one. It has to be understood well. Yes, I was talking about tanks, but yet still I had to talk of something else as well. Construction is very complicated work. We have to understand. So much thoughts are used, so many principles applications are used. You should realize that now when we say you have to construct a tank, means you have to design a tank for storing LNG in that in compressed form. When you compress some gas, Yes, let us say now something about tank. It said that these components are more meant to store liquefied natural gas. Components compose Russian. Hmm? It is 80,000 cubic meter capacity, each within cryogenic steel tank. You know cryogenic, what is cryogenic? Lowest temperatures. Uh, this quantity is not very small. It says RCC with pre-stress arrangement, RCC with pre-stress arrangement for cables, structure of about say 80 centimeter walls. Here we are doing engineering with the reverse size. to make that capacity, you have to design and design. Did it? So you can say RCC with pre-stress arrangements or cables, structure of about 80 meter diameter, say 800 millimeter thick wall, as well as provided with a height of thick wall, as provided with a height of say 50 meters, was included for LNG tank. Now, wait. Actually, maybe our assistant, let me announce what I say. Now let's go further and see LNG spillage prevention. Each tank base was allowed soil improvement below ground by many meters, including many meters depth of granular and granular, can say engineered fill. We fell and the additional phase. And he followed. So we can say that each tank base was allowed soil improvement below ground by many meters, including many meters depth of granular engineered fill in layers exceeding considered. It's not necessary to know everything sometimes, but to write something based on experience. Now, soil improvement below ground by many meters. You can say then granular engineered fill in layers, thickness of fill not exceeding more than 200 each. RCC raft foundation was laid on improved fill, pre-engineered formation after ensuring achievement of required design safe bearing capacity. Top of tank was covered with a permanent formed cupola structure raised to its level by now you can say top of tank was covered with a permanent cupola structure raised to its level by using compressed air pressure lifting. Now cryogenic cryogenic steel was included for construction of LNG tank to maintain about minus 60 degrees temperature Celsius temperature of condensed gas. Then you can say concrete of circular walls was poured using quick form proprietary paid and then you can say there concrete of circular wall was poured using quick form proprietary and custom designed formwork in 5 meters lift each. A cantilever operational platform was constructed on cupola edge as protrusion horizontally. An on-site design area because in that case this is a cantilever operational platform was constructed on cupola for nearly in that case you can say an on-site designed plumbing system was erected temporarily for carrying out concrete curing actively throughout on full height of tank height of tank. can say you can say that an on-site work is done for everything. Then curing was imported and plumbing was done. You know, for each LNG tank was provided with RCC spillage below groundwater tank externally. Now, this was just for tank. I am not giving total description in this. I will go to define something else also, which are very important as well. Important in every sense, we must understand that. We must understand it. Everything is important in construction industry, and we should be really pleased with that. To learn more and more, because learning has no limit. But we have to learn clearly. It's not in doubt. It should not be in doubt. If we learn doubtful, I think it's no use. We should learn facts. Because if you don't learn facts, you can say you lose something in a drastic way. I'm back. So क्या करेंगे भाई. Compressor foundations. Compressor. It's not ordinary compressor. Machine compressors, you can say. Compressor foundations are to be installed as part of various processing trains. These are required to be installed as part of various processing trains for ethylene production unit, being heavy reciprocating machines to be installed on massive foundations at elevated levels. Tabletops would be constructed resting on massive concrete foundation concrete for one cracking gas compressor, being say 400 cubic meter about, say 25 meter long, or say 12 meter wide, as well as say 2 meter deep. Well designed machine foundation for a reciprocating vibratory equipment. This foundation carries thick columns. Thick member means sectional size greater than 0.8 meters and quantity more than 8 cubic meter. Above to support tabletop. Steel plate built inserted between equipment and tabletops, between equipment and epoxy grout. Steel plate built inserted between equipment and epoxy grout. Tabletops are constructed of thick framed slabs resting on thick columns. Planned arrangements of tabletop slabs are complicated in all respects regarding civil as well as mechanical inserts. Such types of thick and massive elements require special type of cement, probably with high GGBS cement replacement, which could also be pulverized fly ash or microsilica or silica fumes. You know what is GGBS, what is pulverized fly ash, and what is microsilica and silica fumes. I have talked many times about GGBS, ground granulated ground or ground granulated blast furnace slag. GGBS stands for. PFA is pulverized fly ash, and microsilica or silica fumes. These particles finer than smoke particles of, when you smoke something, particle size of smoke is, that size is higher if you compare to microsilica. Particular arrangements are worked out for curing solutions for such low heat generating cements to effect thermal curing methods, utilizing no direct contact with curing water, but thermal curing methods. I explained them in brief, but now I'm just giving you requirements. It should be made clear that foundation block is massive concrete and not mass concrete. Don't be confused. It may not be misunderstood as mass concrete. Massive block is higher in status than thick element. Massive block requires a special method for pouring concrete as well as post concrete pour thermal curing, which means the water should not be used in direct contact with concrete, such as flooding, which is very common method of curing of ordinary thin structures. But evaporation volumes released by concrete should not be allowed to be or to leave concrete. You can say but cure concrete by use of thermal energy. Pouring of such pouring of such mass block should be conducted by steps formation during pouring operation without forming of cold joints. Not allowing evaporation and using this evaporation do curing, not allowing of evaporation and using this evaporation do curing is named thermal method. Cracking gas furnaces. This is another one. Cracking gas furnaces. This means for purpose of cracking gas. This meant for purpose of cracking gas received from refinery as a byproduct for transmission to compressors for production of ethane as well as propane. These are all heavy structures, vertically oriented in group of vessels and found on a common base. Other structures included wash water structures, auxiliary boilers within processing trains. Within processing trains. Included wash water structures, auxiliary boilers within processing trains. Also included various vessels such as spheres to contain gases as well as tanks for storage. That is, spheres to contain gases as well as tanks for storage. Now, foundations for tanks are generally constructed of RCC ring beams. Other structures are generally provided with independent footings stepped using grade beams. There's another structure, this is called seawater basin, that's used for cooling water storage and circulation. RCC open reservoir, I'm talking about seawater basin. And a RCC open reservoir meant to continuously collect water from sea through, let us say 2 number, it was done somewhere, that's why I'm writing, not necessary, depends for design. 2 number 84 inches pipes. 2 numbers 84 inches pipes store in this reservoir. Supply to plant various trains requirements, and after cooling installed system use this water to be disposed of from various industrial locations to this receiving basin and then further to outfall chamber. Now, should this water or may this water not be used for process unit system cooling, or it could not be recycled. It's a huge voluminous open structure constructed of RCC base slabs. It's huge voluminous open structure that is constructed of RCC base slab, provided various contraction and construction joints during its executive on-site construction, peripheral retaining walls up to 12 meter high, not more than 9 meter length of panel, as well as covered pump, house unit areas and baffles. Such structures must be watertight effectively. from all locations of water storage portions, duly tested for water tightness conforming to BS 8007 criteria or applicable Eurocode. Ensure Eurocode water retaining structures reference, since BS structure related codes have been stopped being referred to since year 2010. Concrete protection is applied for both below ground as well as above ground RCC surfaces. Testing would be little cumbersome for many days, and factor to be used for computing evaporations losses was complicated since no pertinent standard data being available. A parallel arrangement as a device has to be arranged to observe real evaporation loss model, result of which could be applied to reservoir evaporation observations. Many days are involved, from start of water filling, autonomous healing of surfaces, and then performing stage-wise applicable water tightness testing. It could amount to 2 to 3 weeks for testing performance, and if results being satisfactory, removal of water from reservoir or otherwise after removal of water, making repairs of water leakage as recorded by an application of resin injection to epoxy repairs, followed by another water tightness testing for final observation of leakage or formal verification of produced water tight concrete. Now, this was about reservoir. Many other stationary as well as vibratory equipments are included for processing plant. Many other stationary as well as vibratory equipment are included for processing plants, for which foundations would be constructed accordingly, either as footings, bases, or combined footings. These horizontal and vertical vessels are erected on these bases, connected using anchor bolts, and grouting done between sighting steel plate and top of concrete. You can say a void between two, that is steel plate of machine and top of concrete. For vibratory equipment, epoxy grouting is applied, while for stationary equipment, cement based grout is suitable. Sump chambers. It's not ordinary sump, it's a big sump. These covered chambers are used for testing. Concrete protection is applied for both below ground as well as above ground surfaces. Concrete protection is applied for both below ground as well as above ground surfaces, which is very important item in water retaining structures. Manholes, catch basins, rainwater ditches, etc. are constructed using RCC material. Manholes are meant for sewerage lines, oily manholes for oily discharge, catch basins for rainwater. Generally, these units would be provided in large numbers for certain plants areas, making it preferable to produce by precasting on site, for which all working details for proposed yards are required to issue to site. Working details for each manhole to be precast is coordinated and sketches prepared showing plan, all internal side elevations, locations of cutouts for incoming and outgoing pipes, and shown real dimensions with details related to its cover and cover framing, along with location of embedded steps in walls, if so required, depending on internal depth of manhole. Open ditches are constructed for discharge of storm water. Open ditches. Now, this is regarding storm water. These ditches can also be used for purpose to give way to fire water disposal during whatever fire break out on installation. Ditches may also be used for demanded purpose of intended water line maintenance, discharge received from some single loop. At commencement, ditch section is considered shallow, but as it reaches moving within various catchment areas, ditch section is gradually and considerably deepened, like resembling a big city drain. Piping. Carbon steel or ductile iron or fiber reinforced plastic family, GRP, ERP, GRE, etc. are included, depending on requirement and structural adequacy, to sustain various impossible stresses. Not impossible, impossible. I repeat, carbon steel or ductile iron, CS is carbon steel, DI is ductile iron, and fiber reinforced plastics family, representation is GRP, ERP, GRE, etc. are included depending on requirement and structural adequacy to sustain various impossible stresses. Stress analysis is carried out for various loops, giving location of various supports as well as anchoring requirements. Various types of supports are designed for varying diameter of pipes for on ground or underground or above ground use. FRP, fiber reinforced plastic pipes. RTRP stands for reinforced thermosetting resin pipes. Reinforced thermosetting resin pipes. A composite material consisting of a thermosetting polymer. Thermosetting polymer, a type of polyester reinforced with glass. Polyester reinforced with glass or other fibers that provide strength and stiffness to composite material. Different types of resins used for manufacturing. GRP, GRV and GRE pipes are isophthalic resin, isophthalic resins, vinyl ester resin, isophthalic, isophthalic resin, vinyl ester resin and epoxy resin. Different types of resins used for manufacturing GRP, GRV and GRE pipes are isophthalic resin, vinyl ester resin and epoxy resin respectively, that are selected according to required properties such as chemical resistance, temperature resistance and other mechanical properties. Such as chemical resistance, temperature resistance and other mechanical properties. These are GRP, GRV, GRE pipes, and resins are used for manufacturing these pipes, and these resins are isophthalic resin, isophthalic, vinyl ester and epoxy resins, and we have to select out of these for required properties such as chemical resistance, temperature resistance and other mechanical properties. Resins provide thermal and chemical properties such as glass transition temperature, resistance to heat, chemical resistance, etc. required for finished product. Properties of GRP pipes can be varied by changing ratio of raw materials as well as winding angle. These pipes consist of 3 layers adherent to each other, each having different characteristics in relation to functional requirement. Particular information, layers for reference only. Let us say layer 1, that's inner liner, we call it inner liner, that's of glass, wheel glass, resin CSM glass, resin, wheel glass, resin is CSM glass, resin, and other one is structural wall, roving, we can say roving glass, resin. So one is internal liner, wheel glass, this is resin, CSM glass, resin, structural wall, roving glass, resin, external liner, wheel glass, resin. Composition. Inner liner, wheel glass, resin, CSM glass, resin. Inner liner layer is chemical resistant. Inner liner is chemical resistant due to remaining in direct contact with fluid and therefore responsible to resist chemical corrosion as well as permeability. Inner surface is particularly smooth to reduce fluid head losses and also opposes growth of minerals and algae. This liner has 2 monolithic sublayers. Inner one is contact with fluid is reinforced with glass wheel with resin content 90%, while outer one reinforced with CSM glass with resin content 70% by weight. So inner one in contact with fluid is reinforced with glass wheel with resin content 90%, while outer one reinforced with CSM glass with resin content 70% by weight. Standard liner, standard liner thickness is about 0.5 to 1.5 mm. Structural wall is in roving glass resin. Roving glass resin. B. Glass reinforced layer. Glass reinforced layers guarantee mechanical resistances of whole pipe against stresses. Glass reinforced layer guarantee mechanical resistance. Glass reinforced layer guarantee mechanical resistance of whole pipe against stresses due to internal and external pressure, external loads as well as thermal loads. I am talking about a structural wall in which roving glass resin, glass reinforced layers guarantee mechanical resistance. Glass reinforced layers guarantee mechanical resistance of whole pipe against stresses due to internal and external pressure, external loads as well as thermal loads. Again I say this is technical statement. Glass reinforced layers guarantee mechanical resistance of whole pipe against stresses. Glass reinforced layers guarantee mechanical resistance of whole pipe against stresses due to internal and external pressure, external loads as well as thermal loads. For GRP or GRV pipes, this layer is obtained by applying on previous partly cured inner liner, continuous rubbing of glass wetted with resin under controlled tension. For GRV pipes, this layer is obtained by applying on previous partly cured inner liner, continuous rubbing of glass wetted with resin under controlled tension. For GRE pipes, structural wall is wound directly on a wet liner. For GRE pipes, structural wall is wound directly on wet liner. This layer can contain aggregates like silica, sand, if allowed by specifications, while thickness depends on design conditions. And this is very technical point. Let me repeat: is structural wall. It says roving resin. It is roving glass resin. Glass reinforced layers guarantee mechanical resistance of whole pipe. Glass reinforcement layers guarantee mechanical resistance of whole pipe against stresses due to internal and external pressure, external loads as well as thermal loads. For GRV pipes, this layer is obtained by applying on previous partly cured inner liner, continuous rubbing of glass wetted with resin under controlled tensions. For GRE pipes, structural wall is wound directly on a wet liner. This layer can contain aggregates like silica, sand, if allowed by specifications, while thickness depends on design conditions. External liner, VL glass resin. Top coat or top coat or external liner is an outer layer of pipe consisting of pure resin. Ultraviolet protectors, UV we call it, ultraviolet protectors may be added if so required to protect pipe from effect of solar exposure. In case of meeting severe exposure conditions such as aggressive soil or very corrosive environment, this external liner can be reinforced with a surfing veil or added with filters or pigments. Fiberglass composites consist of glass fiber, reinforcements, thermosetting resins, and additives designed and processed to meet specific functional performance criteria. General amount, type, and orientation of glass fibers in pipe provide mechanical strength. Amount, type, and orientation of glass fibers in pipes provide mechanical strength. C-glass, E-glass, and ECR, Advantex glass are used commonly depending on pipe application. Various forms of glass reinforcements are named as surface wheel, chopped strand mat, that is CSM, chopped strand mat, chopped rowing, filament rowing, and woven rowing. Raw materials like catalysts, accelerators, inhibitors, aggregates, and pigments are used together. These are raw materials like catalyst, accelerators, inhibitors, aggregates, and pigments are used together with resin and glass reinforcement to achieve desired properties of fiberglass product. Catalyst is an organic compound. Which, when added to resin in presence of an accelerator, determines polymerization reaction at ambient temperature. Catalyst is an organic compound which, when added to resin in presence of an accelerator, determines polymerization reaction at ambient temperatures. Accelerator is a chemical compound. Used together with a catalyst to shorten polymerization time. Inhibitor is added to resin to reduce reactivity at ambient temperature. There are two manufacturing processes, one being dual helical filament winding process, and another being continuous winding process, or can say Drost-Hall. Pipe racks. This is another component of plant, and also very important component, that is pipe racks on which pipes are carried. Pipe racks, you can read this. I'm just one place, just thought 2 minutes. I'm a little relaxing. Pipe racks are used for required purpose of running piping from one point to other over ground levels. These are generally constructed of steel structures founding on RCC footings, but RCC frame structures are also used or included. Several kilometers of pipes are run over these racks, supported and anchored to rack structures. These are fully accessible structures for maintenance purpose. Open steel or plastic flooring is provided for stacking. Now, very important part, heat tracing. Heat tracing. Heat tracing. It is applied on piping carrying -degree gas in liquid state, which may freeze during its flow and block flow within pipes, for protection of which heat is continuously maintained on piping to keep borne carried gas in condensed form. Various loops are provided on piping routes for various purposes. Let's see now pipe supports and sleepers, which is very important part. Pipeline domination by this system. I'm just trying to brief you about certain components which are really interesting construction education work. Pipe supports, pipe sleepers. These are used for purpose of carrying pipes at near ground level. These are used for purpose of carrying pipes at near ground level. These are RCC units located at defined spacing. For direct support of pipes, steel structural supports are employed. Remaining either connected or touching pipe by shoe over lengths at various spacing, meant for purpose of sliding also. For deciding locations of such supports and their anchorages, stress analysis is conducted, which dictates required design spacing, dimensions and pipe structural base design. For a pipe of diameter not more than 4 meter, not more than 12 meter spacing, is generally adopted for a pipe of diameter not more than 4 meter, not more than 12 meter spacing is generally adopted. For others, smaller diameter pipes, spacing depends on standard length of pipes. Pipes that need sliding movement at joints are provided with such a base that allows movement of pipe in direction of its run. For other smaller diameter pipes, spacing depends on standard length of pipes. Pipes that need sliding movement at joint are provided with such a base that allows movement of pipes in direction of its run. For that purpose, PTFE, PTFE, that is polytetrafluoroethylene bearings fixed on steel plate. Pipes that be known for that purpose, PTFE polytetrafluoroethylene bearings fixed on steel plates duly designed to withstand imposed forces are provided. Below pipe support, below pipe support, shoe steel, below pipe support, shoe steel portion, a stainless steel plate is provided so that this plate slides over PTFE pads. Pipe supporting sleepers, which is another very important part of piping. Pipe supporting sleepers and big sleepers, we can say anchor sleepers. These are very big sleepers, thrust blocks, etc. are employed at various points. Big sleepers and thrust blocks are applied at various points, locations depending on stress analysis requirements on en route application. So we can say anchor sleepers, which we are saying big sleepers, thrust blocks, etc. are employed at various points, locations depending on stress analysis requirements on en route pipeline. These are thick and voluminous structures requiring 1000 cubic meter RCC and 1000. These are thick and voluminous structures requiring 1000 cubic meter RCC for an individual sleeper connecting a group of pipes. One pipe loop, on pipe loops, various kinds of stresses from all directions are imposed upon during operations or flows. Then you can say on pipe loops, various kinds of stresses from all directions are imposed upon during operations or flows. Now, on pipe loops, various kinds of stresses from all directions are imposed upon during operations or flows which are resisted by these sleepers. A change in direction of pipes routes as well as T locations, etc. Big sleepers or thrust blocks are provided to resist resultant forces. Then at changes in direction of pipe routes as well as T locations and then is at changes in direction of pipe routes and at changes in directions pipe routes as well as T locations, big sleepers or thrust blocks are used. Then you can say these sleepers are constructed of RCC, and you can say these are constructed as RCC massive blocks. Let's go to access platform. Access platform, very also good item, very important item as well. Access platforms are constructed to access to an area above pipe level for maintenance purpose. For maintenance purpose, EOT, you can say electrical overhead train, EOT. EOT cranes are applied over low pressure. Now, these platforms we are talking of installed for each maintenance as well as lifting and placing pipes and other operating items in shops. These also meet crossing over pipes requirements. Proper ladders, handrails and open floorings are provided for safe access. RCC box culvert. RCC box culvert are included for various crossing pipes below roads. For various crossing pipes below roads, road crossings, pipes, culverts are also included wherever required. RCC box culvert are included for various crossing pipes below roads, road crossing. Pipe culverts are also included wherever required. Then pipe culverts are also included where required. For accommodation of spillage tanks, RCC box culvert I was talking about. So N, mm, sorry, are included. mm, RCC box culverts are included for various crossing pipes below road crossing. Pipes culverts are also included wherever required for accommodation of spillage or accommodation of spillage. Thanks. Pipe culverts are also included wherever required for accommodation of spillage tanks. Embankments is constructed around to contain oil during spillage. Pipes are connected to culvert space slab using steel connecting arrangements. Enough space is allowed for maintenance purpose for free movement as well as for circulation. Receiving basin. Receiving basin is meant for collection of used water from processing units for intended purpose to further discharge into provided outfall at sea. It's meant for collection of used water from processing units for intended purpose to further discharge into provided outfall at sea. This basin is also given a considerable structure size for collecting water from various returning piping headers, discharge, letting it accumulate and then dispose into outfalls channel for further permanent discharge into sea. Uh, Various types of steel stop logs are installed. Various types of steel stop logs are installed to control flow according to provided capacity of channel and receiving basin, keeping appraised also relevant maintenance function of provided piping. The structure consists of RCC retaining walls in flow direction RCC retaining wall in flow direction, and RCC base slab. Flare towers. Flare towers are required to establish a system to be disposed safely into environment released gases that cannot be used any further, keeping in view that composition effect of such disposable gas does not deteriorate existing environment. Height of such towers is kept considerable so that gases are burnt away into environment safely. Proper arrangements are designed for founding as well as checking stability of such tall structures. Pump houses. Pump houses are installed as large size and highly elevated steel buildings. Large size and highly elevated steel buildings housing a train of various pumps, electrical equipment, chlorination plant, rotary drums, intake equipment, etc. Piping is routed on ground vertically as well as horizontally on various types of supports having complex design. Various types of structural steel access platforms are built for operational and maintenance purpose. Water is pumped into supply manifolds located just outside where chlorination is applied, and pipes are run on overstressing. Water is pumped into supply manifolds located just outside where chlorination is applied, and pipes are run to main route on ground up to various industrial users. Hundreds thousands cubic meter RCC structures are built for supporting bases as well as for anchoring arrangements. General components of for other facilities. General components for other facilities, these are train, let us say, that indicates separate process trains. String indicates parallel process lineups of equipment within a train. String indicates parallel process lineups of equipment with a train, common to be used for equipment that does not exclusively belong to one train but several total complex. Process unit. Yes. So, process unit. Now, slug catcher. Slug catcher, condensate stabilization column, flash gas compression, acid gas removal, dehydration, mercaptan and mercury removal unit, operating plus regeneration. Sulfur recovery unit. This which was this slug catcher. Then there is sulfur recovery unit. Sulfur recovery unit, sulfur degassing, clause of gas treating off gas thermal oxidation, NGL extraction, NGL natural gas extraction and fractionation or fractionation, overall refrigeration unit, LPG and ethane treating unit, that is LPG ethane unit, field concentrating field consolidate you can say NGL extraction and fractionation, overall refrigeration unit, LPG and ethane treating unit, LETU, that is you can say LPG and ethane treating unit, LETU, okay, LPG and ethane treating unit, field condensate treating field field condensate treating and plant condensate treating, LIN, LOX storage and vaporization, air separation unit, ASU, SGP reactors, syngas treatment, steam methane, and then you may say steam methane reformer, SGP reactor, syngas treatment, steam methane reformer, TSMR unit, 1 SMR plus 1 pre-reformer, 1 into 50%, 1 SMR plus 1 pre-reformer, and hydrogen manufacturing, 1 high temperature shift and PSA unit with compression, 1 into 50%, 1 high temperature shift and PSA unit with compression, heavy paraffin synthesis, water distillation unit, catalyst activation and regeneration, light and stripper, light detergent feedstocks, heat paraffin conversion, heavy paraffins conversion, synthetic crude distiller, high vacuum unit, catalytic dewaxing, catalytic dewaxing, base oil redistillation. Reliability and availability. Reliability and availability. Particular system uptime are key project drivers. Particularly system uptime are key project drivers. A system's effectiveness model. A system's effectiveness model shall be developed for complex. System effectiveness model shall be developed for complex, comprising base cases, configuration of offshore facilities and GTL gas to liquid plant configuration, feed for project units, so that required overall system effectiveness of 335 steam days. A system's effectiveness model shall be developed for complex, comprising base case, configuration of offshore facilities and GTL, that's gas to liquid, plant configuration, feed for project units, so that required overall system effectiveness of 335 steam days per annum is reached in a cost effective manner. Overall system effectiveness of 335 stream days per annum is reached in a cost effective manner. Offshore development concept is based on direct transportation of produced fluids. Offshore development concept is based on direct transportation of produced fluids and gas from wells on platforms to shore without any offshore process or treatment. So offshore development concept is based on direct transportation of produced fluids and gas from wells on platforms to shore without any offshore process or treatment. From each platform shall be multi-phase carbon. From each platform shall be multi-phase carbon, steel trunk line, multi-phase carbon steel trunk line to common slug catcher. Chemical injection and regular pigging. You can say offshore development concept is based on, we have seen this, from each platform shall be multi-phase carbon steel trunk line to common slug catcher. Chemical injection and regular pigging shall be applied for corrosion as well as hydrate formation inhibition to provided carbon steel lines. Produced fluids are received into slug catcher in upstream onshore facility. Now, produced fluids are received into plug and slug catcher in upstream onshore facilities. Onshore upstream comprises now onshore upstream onshore upstream comprises what it comprises. Let us see. Onshore we are talking, it is slug catcher that goes to condensate stabilization. Slug catcher goes to condensate stabilization, which goes to acid gas removal, goes to sulfur recovery and storage of gas, treating or SCOT, that is unit dehydration and mercaptan removal, NGL extraction and fractionation, final treating of of no, so we can say NGL extraction and fractionation, final treating for finished NGL products, LPG and ethane treating unit, field and plant condensate treating. I repeat, onshore upstream. Onshore upstream comprises slug catcher, condensate stabilization, acid gas removal, you can then, once again slug catcher, condensate stabilization, acid gas removal, sulfur recovery and storage, SRU off gas treating or SCOT, unit dehydration and mercaptan removal, NGL extraction and fractionation, final treating and finished NGL products, LPG and ethane treating, unit field and plant condensate treating. Onshore upstream facilities, condensate and water, kinetic hydrate inhibitor, and corrosion inhibitor X-slug catcher are separated. Water, water, yeah, water, all very hot. We can say onshore upstream facilities, condensate and water, kinetic hydrate inhibitor. Then water is sent to a decided dedicated mass. Hmm. Onshore upstream facilities, condensate and water kinetic hydrate inhibitors (KHI), and little relaxing in between for a minute, just for your information, because feeling tired on shore upstream facilities, condensate and water kinetic hydrate inhibitors and corrosion inhibitors, slug catchers are separated. Water is sent to a dedicated effluent treatment which caters for KHI, kinetic hydrate inhibitors and possible saline components. Condensate is stabilized and treated. Condensate is stabilized and treated for sulfur removal, conversion for export sales. Wet feed gas, X slug catcher. Wet feed gas X slug catcher is routed to gas treatment followed by NGL extraction and fraction. Gas treating facilities remove sulfur components, water, carbon dioxide and mercury from feed gas. Gas treating facilities remove sulfur components, water, carbon dioxide and mercury from feed gas. Treating of ethane recovery and treating facilities shall be installed later, and LPG products to further remove residual traces of sulfur, water and carbon dioxide. Treating of ethane recovery and treating facilities to be installed later, and LPG products to further remove residual traces of sulfur, water and carbon dioxide. Sulfur components so removed shall be converted to elemental sulfur for export liquid sulfur. Sulfur components so removed shall be converted to elemental sulfur for export as liquid sulfur. Onshore downstream synthesis. Onshore downstream synthesis comprises gasification process. This is air separation unit, heavy paraffin synthesis, catalyst activation and regeneration, water distillation, steam methane reformer, hydrogen manufacturing. ASU main purpose shall be to produce oxygen and oxygen for use in SGP, as well as also produce HP nitrogen for CAR unit, LP nitrogen and compressed air for use as site utilities. In SGP, syngas shall be produced from natural gas NG and oxygen by partial oxidation. Syngas SGP produces majority of syngas for subsequent conversion into a synthetic heavy paraffin streams in HPS. Syngas requires treatment to remove soot and undesirable byproducts. In SMR, hydrogen-rich syngas shall be produced from NG and steam by a catalytic reforming process. SMR syngas has a higher H2 content than SGP syngas and is used to supplement syngas feed going to second stage of HPS reactors. Reaction on HPS follows Fischer-Tropsch chemistry and produces significant quantities of processed water as a byproduct. WDU WDUs shall be used to strip hydrocarbons from processed water, which we subsequently send to effluent treatment plant for recovery. CAR units shall be used to regenerate HPS reactor catalysts. HMU uses a high temperature shift on a part of a SMR syngas and a PSA unit to produce an ultra pure H2 stream, mainly for use as a reactant in SMR and liquids process units. I'm just giving you all this technicalities not from my own knowledge but it's reference only which I collected from some project just for sharing with you about how we can use. Means it's a kind of generalized collection just to how can it be added to our format. This is not a specialization, just reference, and we can do whatever we have only for your information. Onshore downstream liquid processing. Onshore downstream liquid processing scope comprises light and strippers, heavy paraffin conversion, synthetic crude distillation and stabilization, light detergent feedstock units, base oil units, high vacuum unit, catalytic dewaxing unit, base oils redistillation unit. There are so many short forms of everything: LES, LDF, HPC, SCD, and base oil HPU, CD, W, and RDU units shall be also collectively referred to as liquid processing units or LPU. LES unit, water, carbon monoxide, and carbon dioxide to be removed. In LDF unit, components shall be recovered and after hydrogenation run down to storage for sales as product. Remainder of HPS product shall be routed to HPC, where paraffin's molecules are cracked and is isomerized into middle distillate range components, which are subsequently distilled by SCD into LPG, naphtha, kerosene, gas, oil, and SCD bottom product stream. In base oil mode of operation, SCD bottom product stream is routed to HVU for further separation into vacuum gas oil, a waxy raffinate fraction, and a residual fraction that is recycled to HPC. Waxy raffinate fraction shall be catalytically isomerized in CDW and then separated into products according to boiling range and viscosity in RDU. In no base oil mode, SCD bottom product stream shall be recycled to extinction back to HPC. For no base oil case, throughout of complex is limited by capacity in HPC, one single maximum size reactor per train. Now, supporting facilities, utilities, we can say the names only. Utility system comprise boiler feed water. These utility systems is comprise boiler feed water, steam and condensate systems, raw, demineralized, potable and service water systems, power generation and distribution, cooling water systems, chilled water and closed cooling water system, instrument and two-layer system, nitrogen system, heat transfer fluid system, aqueous ammonium system. Utility systems shall be designed to allow standalone operation of GTL complex. Steam and gas turbines shall be provided for shaft power and generation of electrical power. Steam shall be generated in synthesis section, thereby effectively utilizing exothermic heat of process reactions. Auxiliary boilers and gas turbines with heat recovery system generators. Auxiliary boilers and gas turbines with heat recovery steam generators shall be included to facilitate black start capacity to enhance reliability of steam and power system. Cooling shall be done principally by air, but cooling water may also be used where appropriate. Steam is principal heating medium, but fired heaters and a heat transfer fluid system shall be provided for specific applications. Supporting facilities, storage and off-site systems comprise relief and blow down system including flares, drainage, collection and primary treatment, effluent water treatment, sour water stripper, flushing oil system, storage and loading facilities including on-site product storage slops and intermediate storage. In general, plant condensate blended with naphtha and GTL products shall be stored on site and transported to RLC harbor for shipping. Field condensate shall be stored in an on-site as well as an off-site shipping tank prior to export via RLC harbor. LPG shall be transported directly to RLC facilities for refrigeration, storage and export. Liquid sulfur shall be piped to common RLC facilities. Scope and feasibility check, design, build, EPC related contracts is always very difficult for company. Scope and feasibility check, design and build, EPC related contracts is always very different for company. On oil projects, promoting company as defined earlier is involved. At top level is owner or promoter. Scope of company related acts are entirely different since it takes policy decision on its charter of facilities promotion project. Immediately after requirements are ensured and funds would be made available either by government or by other funding institutions or public equity whatsoever. As a promoting company, it has a top responsibility to manage all sources that would be required prior to commencement of project, during currency of designs, during currency of execution, and thereafter during defined or considered period of 30 years design life of plant facility. A 30 years long period is considered adequate for purpose of targeting durable life of plants, keeping in view services rendered by structures, changes in technologies and other logistical and strategy factors, etc. Company charters facility project considering all points with brainstorming among all states and non-state stakeholders, including banks and policymakers. Once it's decided the plant project is justified and should be put in working in the defined years period, a start of sign is entered on charter is made, defining initial budget and continuous schedule, funding flow declared in form of financing methodological charter. A project team is constituted by a promoting company to head project from its initiation with its performance, testing and commissioning. A land acquisition team is constituted by head the team to conduct land requirement surveys, bathymetric surveys to delimit battery and chart out an obstruction appearing on way within proposed lands. This team supports to head committee team about its progress of surveys and all relevant details, allowing government administration process formal land acquisition and allot to project title ownership. Once land is acquired, whole land parcel shall be required to be secured by fencing around with due legal notifications and signboards declaring it plant owned land. A survey team for land geography and geotechnical details collection is constituted, who would submit its report to project team within a couple of either week or months, depending on size of land parcels. A design team shall be charted out by appointment for its objective to study processing technology and work out pre-feed and feed details and and documents all contents in line to area geography, climate conditions and habitation around project. If habitation within land parcel and around is of such a nature that all occupants may be rehabilitated without causing any obstruction or objections from its residents, there will be imported no serious legal issue, which means process for rehabilitation should start within a defined time limit. Facility areas habitation is not permitted due to risks related available possible chemical adverse effects on residents' health, which precaution must be applied, and in case there appears to be some non-political or political hindrance, project may be prorogued till obstruction is cleared. Feed documents shall be submitted to project team and planners for approval, and after its being authorized, feed shall be used for purpose of inviting design bids from consultants at national and at international levels, who after having been awarded would work in collaboration with EPC contractor as an integrated team. Feed should contain all requirements related to each and every disciplines, including design and specifications, pertinent all equipments and vessels, whether stationary or vibrating, that would be included within each train permanently on conducting chemical processes activity. On certain items which may be designated long lead could be initially placed in order by project team. The initial agreement would certainly be novated. Original contract between company and vessels manufacturing is transferred in all respects to non-contract third party, which in this case being EPC contractor, to vessels procurements, related contracting party in each and every respects of its design, production and performance. Once field is approved, design contracts are awarded. Designers immediately works on draws designs, and if so required, feed may be modified or further research be carried out to meet feed requirements. Designers are required to work out designs related to respective disciplines and issue drawings with complete schematic details so that concept about proposed works be known. Designs could be, in many cases be an integral part within a EPC contract in absolute terms, in which case complete plant design is required to be effected by prime EPC contractor, while in all cases designs and execution organizations constitute alliances to carry out respective designs and executions on prime contract's part respectively. And for prime contractor accountability and obligations, it gives in prime contractor scope complete executive works, design, approvals, prosecution, procurement, installation of vessels and equipment, construction of all buildings and all structures, all external and internal works, all services installations, all internal road network, etc., and all other works required to be completed from initiation to performance, testing and commissioning, and handover to company, entire scope as delivery. Clause 1, it was wonderful, I can say, long listed talk, of course with certain boring time, you can say certain technical terms which may not be conversant with, but only indicatively. Just as I said, I have used references because sometimes references are important just for information so that you may get something out of that. It's not necessary that this be linked today, but only for purpose of writing scope. What should be resolved, it doesn't matter because this is very important talk about EPC, and it's not, minor yours. It's question of how to handle, how to compose, how to design, how to draw. Not thing you use for yourself means it's for understanding. Everybody learns in life. Books are written, references are given, and it moves on like this. Nothing is original. Learning and using, it's only for reference that this can be or this cannot be. It's technological requirement. It's technology that's used in plants. So I'm not using technology. I'm just using what can be done, what cannot be done, only to understand method, and in this case quality method, that is AnnexSL of ISO 9000 we are talking of, and how to work on that annex, how to work on that requirement, which is really interesting for every engineer. We have to update ourselves. We have to learn as much as possible. It's not that I'm going to use all this, but if I get again same type of nomenclature on some other project, I should not be very much concerned with that. I know all this means such nomenclatures are there. I'm not going to weigh out or analyze everything, but you have to coordinate, you have to collaborate, you can say, with all as far as such issues are concerned. EPC or construction or whatever all relate to engineering. That is wonderful. Engineering is umbrella, and we have to stand below that umbrella. It may be designs, it may be construction, it may be whatever else, it may be consultancy, or it may be contracting. All are important. Nobody can say I am important and you are not important, because ultimately it is project end. That project has to go to operation, and that is final goal of everyone. Your contribution may be in designs or in planning or in contracting or in construction or in supervision or in quality or in analysis or in safety, whatever be your field of scope. Within scope, your field may be project scope, you can say. In that scope, you have to cooperate. You have to give your contribution. You have to contribute, and as much as you can contribute, that becomes your credit. Now, credit is not a question here, in fact, but credit is valued. When you say credit, this means your value. Credit doesn't mean certification, I am saying here. Your contribution, your use, that is, you can say, value. And moreover, it's not value that somebody would give you. It's your own value, your own earning confidence. As many projects as you do, that much you learn, as well as that much you teach also. I am not only interested in learning. My more interest lies in teaching, because when I work on projects, I have to take care of my ordinates, my subordinates, their subordinates. Everybody has to learn. If you are in higher status, you have more opportunity for being exposures. You get more exposure than those who are in lower positions. They don't have access to all documents, but you can help them understand as much as possible. Because during career, they have also to move upwards, vertical movement, and they can move only they have an opportunity to get more knowledge. And we know knowledge is not permanent here also. Technologies keep on changing, and today we are talking of this, or it was done many years back, many years back, say 20 years back. So we are just reviewing, just refreshing. Technology might have changed. I cannot say it stands same. And moreover, the life of that project, that plant is now almost 20 years or 21 years, maybe 8 or 9, 10 years more. And meanwhile, as it itself says, technologies change, more and more advancement appears and is taken in. So it's life, professional life is like that. Today, today it's this, yesterday it was that, tomorrow it will be this. Means it's long-term change, but there's something which can't be changed. For example, you can't change formula in calculations, you can't change calculations, you can't change contemplation, you can't change understanding, you can't change your thoughts, you can't change your conception, you can't change your power of thinking, you can't change something which is beyond your control. Technologies vary, methods vary. So many things may vary, but so many things don't vary. So I'm interested in making a habit where quality must always move on, upgrade. You must have habit as a quality person, not as a person, as a quality person who is always hungry, who looks for more and more quality information to improve existing or obsolete knowledge to renewed knowledge. Of course, I know it cannot be applied, it cannot be achieved all time. It takes time. It takes sometimes years to get more information. But it is like that. It is engineering field. And because I am talking of EPC, that is engineering in itself is involved. And engineering is not a small word. It's very wide word, engineering. It assimilates within its scope, within its control, within its spectrum, everything. That is engineering. So we should be very much enthusiastic about this to know what is engineering, how it works, how it should do. That's very important point. If we cannot do that, well, I think it shall be a cause of concern, and that cause of concern should be, taken out of. Cause of concern should be recovered to solution. Concern always is not good. We have to make sure that whatever is concerned is resolved. That's very important point. We have to be very clear about. Why should there be cause of concern when we can solve it? This cause of concern should become cause of solution, cause of suitability, cause of application, cause of, you can say, free solution. That's what it is when say E stands for engineering. So engineering means procurement can be done only when engineering is done, and construction can be done only when procurement is done. And it's procurement of equipment, procurement material, procurement resources, procurement machine, procurement technology, procurement of all required inputs. Whatever we say should be. And that's what is very simple, to be very frank at end. It's not that complicated as we are thinking. Well, I think that's best policy to understand if we can do. And I think I should now close this because it's time. I don't want to put more. With this, I thank you very much, gentlemen. You're all here. I think you enjoyed this technical and little boring talk. Boring is also enjoyable sometimes, and I'm very much bored. I know I bore you very much for hours together, which no one likes. But this is engineering. Time is to be devoted to this. Only then we can say something. Otherwise, we can say we waste time if we don't go, we don't move like this. And this is very important. I did not complete this today. I'll take more time on this because I have to further move on to others, and I just wanted to share such information with you. And that share, I think sharing is better for you. You can see file itself. I'll talk later on something else. With this, thank you very much.